Hello and welcome to this third video in our tutorial series where we're looking at doing things in 3D with JavaScript. And we've got a potential planet called our egg planet, which in this video we're going to get some moons orbiting around and maybe do a mini solar system. Also there's a fly in here as well, so hello from the fly. Right, let's get into the code. Let's get straight in there. Right, I could delete that. To begin with, I was trying to load a model in there and it kind of worked. Maybe I'll try that next time. So, you know what we can do? We can comment out our texture, because we won't be using a texture here. We've got at the moment a specular material on our planet, and it's 200 in terms of its radius, and here we're determining the resolution, how many segments we've got in our planet. So let's get a moon orbiting around. Right, I've got an idea. We could reuse this function, our render egg planet. What we could do is, instead of translating to these locations, we could pass in some variables here. Let's do that straight away. And then we could call this again. Let me show you what I mean. We could say something like render egg planet, and then say we wanted a moon, we could say I want it 300 away on the x-axis, keep the y and the z-axis the same. We could then say what size we want the planet to be. Our egg planet is 200, so we can make this one about 42, and then, yeah, that's about it, something like that. And then our egg planet, we would want to say, well, we want this one at 0, 0, 0, so in the center of our 3D scene, and we want it to be 200. So then we want to pass these variables into these parameters within our function. And then we've kind of got a bit of extra functionality. Right, so let's just say x, y, z, and radius. And then replace those here. X, y, should be using my mouse, z, and radius. Right. Oh, it's actually written radius, that's weird. Did I write radius up here? No, that's just a weird coincidence. Okay, so in our draw loop, now we should be drawing two celestial bodies or cosmic bodies. One 200 in radius 142, and our moon, let's get some comments here. This should be a moon. Right, let's see if this actually works. I've forgotten to look at the time. Okay. I can have a bit longer. We can have a bit longer together in this video. We've got a moon, and it's orbiting, so we must have some rotation on somewhere. Actually, I don't know if you can see this. Depends how good a quality the video will be. But our egg planet, you can if you look around the light spot, you can see that it's actually turning. And what's happening, I think, is that. Oh, and also we can't. Sorry, I'll continue that thought. As it's rotating, the orbiting moon isn't actually orbiting around. It's just like they're fixed together, and as our first object moves around, it kind of twists around this like child object, like that. So that's one way where we can accidentally create an orbiting effect. But really, our central planet is rotating on its own axis, which you might not want to do, especially if you've got a texture on there that you don't want to see rotating. So really, we've got to correct things. The thing that I interrupted myself with was, now when I'm moving my mouse up and down, we're no longer getting a zooming effect. So we still want our zooming effect. So let's correct those couple of things. So we want to stop, we want to have the rotation happen according to the moon itself, rather than being kind of fixed to the rotation of our central planet, potentially. and we want to make sure that our zoom is working again. So this is our zoom, and beforehand we were changing this variable EPZ, which is no longer involved here. We could put in our translate call, we could write EPZ plus Z. Let's see what happens there. Hope that makes sense, what I've just done there. So now, yes, when I move the mouse, both of those celestial bodies are now moving relative to EPZ. Okay, I'm not sure though that that's a good solution. I think it will move each body in a different way. Let's try and demonstrate that. First of all, let's get a bit more of a zoom. So at the moment, we're mapping from the mouse Y going from 0 to height. We're mapping that to 0 to minus 100. And remember, minus is down the Z-axis into the scene. So let's try 1000. So now when we move our mouse, we should get a bit more of a zoom. There we go. And you can kind of see when I'm zooming out, it's not just due to the perspective, but I'm actually changing, yes, you can really see it there, I'm changing the distance of our moon from the planet at the center. So the orbital radius is changing, which we don't want to happen. So let's correct that. So we want a different zoom mechanism. This works fine if you've just got one object in there, but now we've got lots of different objects. We want to be able to move the whole scene at the same time. So we'd do that with something we're already familiar with. Let's just comment this out. We would do this with the translate function. So before we draw our objects, first we want to say translate to, and now we can put EP X, Y, and Z. We could just put 0, 0 because we're not really changing X and Y, but maybe we want to move along the X-axis and up and down later on. EP Z. Okay, and in fact, that means I do need to use this. That's fine. So we do want to change EPZ with our mouse direction. We also, though, now want to take out from the render egg planet function, we want to take out that relation for the Z component there. Okay, I also want to increase the orbit speed so I can see some things going on. Where's orbit speed? There we go. EPR, standing for rotation. So let's make it 20 times as fast. There we go. And one more change before we go. I'd like to have the moon a different colour. Now the trouble is we're using the same function, and so it's referring to this, it's using this specular material. Let's have something like this. Let's have a choice. We've already got two materials. Let's show you a new material. I think it's called normal material. And what that does is for every vertex that makes up, so that's like a corner in 3D space that makes up your model, it chooses like a particular colour, so you end up getting this lovely rainbow coloured object, I think. So we could say if C equals 1, then have an ambient material, if that, and if that, there we go. And really we should have else ifs to be careful. Right. There we go. So now we can pass in a C argument, and if C is 1, we'll have an ambient material, specular, or normal And our ambient, let's make this blue. And we could go for a bit of alpha, a bit of see-through. So if you put 255, then it's just going to be opaque, so you can't see through it. If you put 0, it'd be completely see-through and invisible. So let's put about, I don't know, 132. 132. And there we go, that should work. And let's have a third celestial body. And I don't know, we'll call this satellite, which I can't spell. Well, that looks right. That looks right. I was unsure about the two L's. And so we want you to be maybe a bit smaller still. No, we're making twin moons. It's a twin moon. And it's going to be 300. We'll start it at the left-hand side of our thingy, our egg planet at the middle. Right. Oh yes, so our fourth, no, 1, 2, 3, 4, 5. Our fifth, 1, 2, 3, 4, yeah. Our fifth argument needs to be the colour. So we want our egg planet to be specular. We'll keep that the same. So that's 2. And then we'll have a see-through planet. So that's 1. And then, or a translucent planet, moon, sorry. And then the other moon on the left, we want 3. And that's going to hopefully be the normal material, which I think is like a rainbow coloured material as its default setting. Right. So we've made a lot of changes, far too many than we should have made. So lots could go wrong. And there we go. A little bit is going wrong. Okay, so we've got our see-through through planet, which looks pretty cool. Doesn't look like that see-through, actually. I should maybe make it specular. It might look better specular. But there's something going wrong with the orbit of our second moon. It's kind of doing like a double rotation. So what's going on there? So there's something going wrong with our rotations, which we kind of anticipated because we said earlier on that really we're rotating the central body, our egg planet, and the other planets are just kind of like moving around with it. Also, we've got a problem in that every time we call the function, we're translating and rotating. And rotations and translations are cumulative, meaning next time you call a translation, it's not going to reset to 0 and then do the new translation. It's going to build on the previous translation and the rotation. So that's why you'll get double rotations and things going silly. So we need to protect for that. Let's protect for that before making it look pretty with different materials. Right. So what we want to do is save the current matrix or 3D coordinate system that we change with translation and rotation. So we want to save the current state of it. And then after we change it with rotation and translation in this function, we then want to revert to that save point. So that's quite easy to do. Sounds quite complicated, but quite easy to do. So before doing any translation, so let's just do it at the start of our function here. You just write push. And what that does is save the current coordinate system. Now we're messing around with that coordinate system with translate and rotation. So after you've done that, we then call pop. And that reverts us to the previous state. So it overwrites anything that we've done with translation and rotation here. Okay, so next time that we call render egg planet for our moon, the rotations and the translations will start 0, 0, 0, and it will go and do its thing. And our render egg planet 0, 0, 0, it will go and do its thing. So hopefully we've got more standard rotations happening. Okay, right. So this time we haven't got any rotations working, but we have got that nice material, which I didn't comment on last time, I don't think, and they are in the correct space. the correct place and position. And when I'm zooming, they're staying at the same relative distance to our central planet. So everything's kind of working, but now we need to just add a proper rotation. And our central planet is rotating, I don't know if you can see it, on its own axis, as are these two moons, our twin moons. They're rotating on their own axes instead of rotating around. So what we want to do is, instead of rotating here, we want to rotate before we translate to the planet's position, or each moon's position. Because if you translate first, you go to that position, and then you rotate from that position as though it's the centre of the world. And so that object itself won't appear to be moving around. Whereas, if you rotate first and then translate, you'll be translating to a different position. So that gives the effect of rotating. So let's see if this works. I'm just trying to work out whether that's what we want. And I think it might be. Let's have a look. Okay, fantastic. So they're rotating around, and our central planet will be still spinning on its own axis, which we could stop by what we could do is add another do we dare add another parameter? So let's put OS for orbit speed, and we can say radians, just times should we put OS in here? No, we'll put it outside. Times OS for orbit speed. And then when we call our central egg planet, that final parameter should be 0. So it's got no rotation. Our moon, let's have just times 1. Our other one, let's slow you down. You could go in the opposite direction. Yeah, we could now say times minus 1.3. And we need to change its position, else they're going to appear to collide. So it's 42, 42, so does that mean 84? I've got to be 85 away to be safe. Let's have a look. Brilliant. Okay. Oh, kind of brilliant. No, they are colliding. I've done some bad maths. They definitely went through each other, I think. Or maybe it was just the transparency of the second moon tricking me. One way we could see this is by flipping the rotations. What if we wanted to go on, instead of rotating around the x-axis, we could go around the z-axis. So imagine a pole sticking through, we could go around the z-axis. And this might be more convenient if we wanted to have like a solar system animation. We could actually see our planets a bit more easily. So all we would have to do is change rotate Y to rotate Z. Let's have a look at that. Oh, the fly may have flown away. There we go. Oh yes, I did. My maths was okay. There's 1 pixel between them, so that's quite satisfying. There we go. So you can make lots and lots of celestial bodies. It's gonna get complicated if you wanted a moon to go around a moon, kind of like a meta-moon or a sub-moon. Let's, with this current system that I've got, let's try that out. And, or let's see if we can also have like a spaceship or something flying around. Right, what did I want to do first with the materials? Yes, I wanted to have our moon having the our egg planet having the ambient material. So I think that was, I've forgotten. I need to leave that 0. Yes, oh no, it flies back. Let's have 1 and 2. That was a parameter for the material. So now we should be able to see through, our central body. Oh, but we wanted that see-through to be specular. Okay, so let's change that here. Yeah, I think when you want to do some translucency, specularity looks better. There you go, because you get these little light spots on it as well. So it kind of looks more like a soap bubble or something like that. Okay, right. What did we want to do? We wanted to try and make a submoon, so let's just think about this. So at the moment, our rotation is working because whatever celestial body we've got, they're all rotating around 0, 0, 0. So what we kind of want to do is, if it's a submoon, so if submoon, we want to kind of translate to a certain celestial body's position, and then we want to, no, that's all we have to do. We just have to translate here. Or what if we called render egg planet from within render egg planet, because then we've actually translated to that planet's position, although then we'll have trouble with the rotation. Tricksy. Okay, let's try it the first way. So if submoon, then we want to translate to a certain position. So how do we get a position in there? We're going to have to pass in more parameters. Okay. And those parameters. Okay, let's just bite the bullet and do that. So we'll call it OX for like orbit, origin or something. Origin X, origin Y, origin Z. Okay, so these guys, we want to say 0, 0, 0, because their origins are going to be the central egg planet, which is at 0, 0, 0. 0, 0, 0. And we should go and test that now. So, I didn't put those in. Origin X, origin Y, origin Z. Okay, so we should translate to the new origin, which shouldn't change anything at the moment because we've said 0, 0, 0, which is the same as before. So let's just make sure, and I'm going to rotate by the y-axis again. Well, let's try the x-axis, so we should go that way, if you imagine a pole going through the x-axis. So everything should look okay. Oh, which it doesn't. Something's going wrong there. Rotate X. Let's just try rotate Z. It was rotate Z before. I may have made a typo or something that's stopping things, although it's still working. Oh no, that's fine. Does Y work? Rotate Y. Did I delete a bracket or something? So Y is working, that's going fine. Let's just try rotate X. Just trying to think why that's not working. Oh, I think I know. I think it's because of the positions of our bodies. They're on the x-axis already. That might be the problem. They're positioned relative to the x-axis. Yeah. So they're just rotating like that. Yeah, so the whole thing is just rotating like that. So if you wanted rotation that way, you would have to say, basically put these numbers in the Y position. That would be fine. Or the Z position. Yeah, in the Z position it'd be like this, and then they'd start going like that. Or the Y position they'd be like this, and they'd go like that. Okay, that would work. I'm not even going to test that out, I'm so confident. I'll let you experiment with that if you want to. So what were we doing? We're making our sub-zone, sub-origin. So things are okay at the moment. Yeah, things are okay at the moment. We can put, let's put Y back in. Also, you may have noticed the transparency, the alpha, didn't really work for our central egg planet. I think that's because there's like a bug maybe in P5, or maybe it's, I'm not thinking about things correctly, but maybe the transparency doesn't work correctly because we're drawing it first and it needs to be drawn last. This won't always be possible to sort out, organise in your own, if your scene gets sufficiently complicated with lots of bodies with different layers of transparency and things. But that's corrected it in the first instance anyway. If you have a simple enough animation and you want your translucent body to be translucent, draw it last. Even if it's positioned behind other objects, it gets drawn behind them if you're drawing it first. So that's how to overcome that bug for P5 WebGL. I'm currently using P5 version 6.1. It's 2018, May, mid-May. So it may have been corrected if you're watching this video in the future. Right, let's make a submoon. Let's continue. So things are working. We've added these 3 new origin parameters, and we are translating to the origin before we do the rotation, because the rotation will be relative to that new origin, which needs to be a planet's location. So let's do a subplanet around our satellite twin. I've just realised this won't work, or will it? Okay, I just realised, do we need to know the actual location, X and Z, on each frame in order to do this correctly? Well, we'll get some weird results if not. Okay, so let's have it be 12 in size, and so we'll say let's just say minus 400 on the x-axis. Its speed, let's make it go quite fast, 4. And its colour, I can't remember them now, let's just put 2. And yes, so here we want to refer to the position of our like parent. So I might just put these two together. So we've got the idea in our code that they're kind of parented. I have no idea. I think this will work. This is quite exciting. Wow, has that worked? Okay, I see what's happening. So it hasn't worked. But what our little object is doing, let's flip the rotational axis to Z so we can see what's going on a little more easily. So it's rotating, it's orbiting around this fixed spot. It's not following the orbit of our multicoloured twin moon. So we need to update its position every frame. So it needs to be called from inside here. I think. Oh no, we need to take into account the previous rotation of our moon, or we need to call recursively render egg planet here. Okay, let's try it. So we need to do it after the rotation. Will that work? This is getting complicated. Yeah, we could do it after the rotation here. Right. Let's see what happens. So I'm just thinking, now it's kind of time when doing it in this very simple way, i.e. doing it by that I mean rendering bodies by calling this function and basically not using object-oriented programming. Every time you want to create a new planet, you have to set all these arguments and think about where they're positioned and things like this, when really we want to do things in an object-oriented way, where they can kind of procedurally generate. So it's basically when you'll have to really think about things and it's getting too complicated and you're kind of hacking it together like I'm doing, it's time to go object-oriented. So let's just try this out anyway. It's nice to do a bit of recursion. So in here, after we've translated and we've rotated, then we can call render egg moon again, egg planet. And now we want to think slightly differently. If sub moon center of orbit. So now we want to pass these parameters in. We don't need to call it up here. And we want to say, now this is going to be, this distance is not going to be from 0, but from the center of orbit, which we don't need anymore. Right. That's what was holding me back. Is that right? Oh God. How do you... So it needs to be after, it needs to be after this translation. So yes, we rotate, and this translation puts us at the center of the planet, and then we need to render the sub-moon. I think. And it wants to be, say, minus 24. Our size will be 12. It'll be colored to... What does 4 mean again? What does that refer to? That's the speed. And so we don't need the origin idea anymore. Okay, because that didn't work. Right, that should be it. But we are saying if there's a submoon. So let's say if sub equals true, then render a new planet, render a new moon. So instead of the origin idea, we'll just say sub. And that's if you want a submoon or not. So our satellite twin, we're going to say true. I think we could leave the other ones like kind of null. That would resolve to false, I think, automatically. But let's just put false in explicitly. Right, let's give this recursive technique a go. Our second idea. Okay. I don't see a sub moon anywhere. That might be because it's inside this moon and I've positioned it wrong. Let's just open up the console by Alt Command J or Control Shift J if you're on a PC. So there's no bugs down there. Okay, so no errors. So let's just have a look at my basic maths again. So how big is our satellite twin? It's 42 and we're only drawing it 24 away. So it's inside, it's kind of orbiting inside that twin. So it wants to be at least 42 away. So 42 plus 24 is 66. Is that right? Minus 66. 12. Okay. I want to go a bit more. Let's say 70. Okay. Let's see if that works. Damn. It was just a theory that it was orbiting inside of our colourful thing here. So we've lost our moon. Where on earth could it be? What's going on? Are we definitely calling it? If sub equals true, so we've got sub up there. 1, 2, 3, 4, 5, 6. It's a seventh parameter. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, here we go. I forgot to delete what should we call them? What's that word beginning with L? That means you're no longer using it anymore. What is it? Redundant. There we go. Legacy. That was the word. Redundant or legacy parameters. 1, 2, 3, 4, 5, 6, 7. Right. That means it could have been working, and now I've just... No, it would have been orbiting inside the planet, I think. Let's see. Oh my god, it's worked. What? Well, there we go. Although it's now flipped. It's affecting the colour. No, it's affecting the colour of its parent. Because the material is set beforehand. I think, hopefully, fingers crossed, we can just move where we set the material and that won't affect us anymore. I'm quite pleased with that. We've got submoons and things going around. You could imagine, I think I'm going to stop the tutorial soon. You could put another parameter in to have like different orbital axes for different planets, which would look good. You know what? The final thing I'll do, I'll just change the materials, but let's map onto our keys some movement. Okay. I've forgotten how long this video is. I said it could be a longer one. It might be, I don't want it to be an hour though. I've got a feeling it's been over half an hour by this point, easily. So let's just see, if we set the materials down here, yep, that should be fine. Yes, that should work. Let's just put some comments in here, let's be sensible. Set material type. If there's a submoon, draw our geometry. Remember, no stroke was turning off the construction lines. I might turn that off, although it can't draw construction lines if this resolution is too high. So we could put that down to 2416, and then it's able to draw the stroke lines on the planets. Yeah, let's just see if that's working. I really want to delete these to tidy. I'm kind of like tidying up the code now, which I shouldn't be doing. That looks awesome. Oh, that looks really cool. The construction lines looks really good. Well, I think, for me, on translucent objects. That's kind of cool. Right. Yeah, that looks really good, except for the collision that's happening. Let's just make sure that our twin moon is a bit further out. So you can say minus 412, and then we won't have that collision with its submoon and the first moon. There we go. Oh, no, it's still just about hitting, I think. I didn't actually do any maths there. Oh, yes, it is hitting. So I need to go further out. 32 should do it. Right, so let's get some movement. So, in our draw loop, we want to be checking if we've got a key pressed or a key held down. So let's do that after we redraw the background. We'll write our own function called check input. And you know what? Our draw loop is now really busy. So let's put all of this into its separate function. Control X, Command X. We'll say function draw, or let's just put solar system. Paste that in there, and then we've got to remember to call that again. Solar system. There we go. That's where our zoom is happening. Okay, it's a little bit tidier now. I don't like that up there. I think we can bring our rotation down here as well. Orbit rotation. That's kind of cool that we've got a speed that if we change this speed, it changes the speeds of everything else because they're all relative to it, which is quite nice. What do I need to do? Right. Okay, so we can see the draw loop on one screen, which means it's fairly tidy. So we were writing check input. So function check input, and let's get side movement happening. So when we draw our solar system, we're translating according to EPX, EPY, and EPZ. EPZ is the only thing that can move at the moment with our mouse. So we could affect EPX, so the x-axis, according to some keys. So to do this in P5, we write an if statement. If key is down, and then I believe it's in brackets, and you put a key code in, such as left arrow, or I believe the A key is key 65. Let's put that. So I can write or. No, I need to do this. I need to say or key is down and key code 65, I think it is. So that's the left arrow key. Then I want to say EPX. If we're going left, we're going minus. Minus equals, let's try 10. While we're here, let's have faith that will work. Let's try going right. I think the key is 68. And so we want X to go plus. There we go. Dare I go up and down for Y? No, let's just see if this works. For the x-axis. So we can still zoom. Our planets and moons and submoons aren't colliding. And I press A key, and I'm going that way, and the D key, we're going that way. Lovely. You could swap the polarity of that. If you wanted the sense of the camera moving, you want to do the opposite of what I did. If I'm pressing A, the planet's going left, which we don't want. We want if you wanted to imagine you were in a spaceship or something. I don't know. So I think that's what. No, I'm going to keep it like that. Or no, I'm not. I'm going to pretend I'm in a spaceship, and then let's do the same thing for up and down. So we can say up arrow. I'll be very impressed with myself if I can remember the key codes. It's 87, I think, and then 83 to go down. And we want EPZ. So let's think. If we're going down, we want the planet to go up. So that would be, so that's going to be Y minus. I can't remember in 3D space. Yeah, I think it's minus. Right, let's go and check that out. And then I really would like a spaceship on screen. Yeah, I got it right. I got the orientation right. So now it gives the illusion that we can move on all axes through space and go and visit different planets and things. So I would imagine that you could build a massive solar system. You could even match it to our own solar system's like speeds of orbit and things like that, relative to one another. You could change the scale of your planets to be real size and everything else. There you go. Again, in the comments, let me know if you want me to do anything particular here. I haven't made a little spaceship. I haven't done that. Oh, you could do it with a texture, couldn't you? With some alpha on and just have it on a flat plane. That would be good. That would be good enough for this kind of view, where we're not really rotating the camera itself. So what I didn't do in this video was look at polar coordinates, which would be a better way, I think, to do all of these rotations, particularly if you're doing different tilts for your orbital kind of movement. But there you go. Thank you very much for watching. Hopefully this video is under an hour, and I hope it's been helpful. See you again. Leave any comments.